This is part 3 of System Design Interview Concepts, and we are going to cover caching and CDN in this video. If you haven't watched the previous ones, you can either click on the link above, or you can just go to the channel and find all the videos available. If you find this video useful, just let me know in the comment section below, and let's get started. Do you know how many words exist in English? It's actually 500,000, but you only need 1,000 of them to have a daily conversation. Given that, would you just memorize all these 500,000 words, or you would just memorize 1,000 of them that you need every day, and whenever you need something more, you would just use a dictionary to learn that new word? And of course, using dictionary would be slower than bringing it from your memory. It's actually similar for your applications. Most of your day-to-day use cases of your application will require just 1% of your data. So it would make more sense to store that 1% of data somewhere way faster than your actual storage. So this is what caching is about. It's storing the parts of your data that will be needed the most somewhere that is faster than going to the actual storage or database. And caching can be in many forms. So now let's see some examples. One example is your browser. Whenever you try accessing some application, for example, for our e-commerce site, maybe you are trying to get list of orders back, or you are accessing this website for the first time and you are getting CSS and JavaScript files to render the page. So your browser might cache this information in client's disk or in your disk, basically here, so that when you need the same information again, it can just get that information from the cache instead of going to the server. Another common example is host level caching. So again, you are calling some application here, and this application is actually, let's say this is our order service. And maybe this order service needs some invoice information, and it's calling invoice service here. So when you get the invoice back, the application server might cache it within the host itself. Or maybe instead of calling invoice service, it's calling its own database and getting back the orders. Again, that information can be stored in this cache, which is host level cache here for this application server. And when next time client calls and tries to get list of orders or some kind of invoice, now this application server or our order service, it doesn't need to go to invoice service or its database. It can just use the cached value here. Another example is distributed cache. So in this case, instead of having some cache in the node level, you might have a standalone distributed cache here, and maybe you have a bunch of services here. And when your user calls your application, instead of this application server going to multiple services and trying to aggregate the data again, it can just hit this distributed cache, and it might get back the order or invoice or whatever information you are storing in this distributed cache. So just to understand the difference between second and third one, in the second one we have something like this. So our application has multiple nodes, let's say node 1 and node 2, and each node has its own cache here. So if user hits the node 1 initially, and if the list of order for this user is cached here, if next time when user calls your service or application, if it hits node 2, it won't exist in this cache here, which means it needs to go to other dependent services or database again to bring the information back. But with the distributed cache, you don't have this problem, because cache is not sitting next to each node or host. It's distributed in a standalone cache here, which means whenever your users are making a request to your application, if it's in the cache, you'll always get it regardless of the host you hit. And one other example is CDNs. So instead of all your users going to your application server or actual storage, they can go to CDN, for example, to get your JavaScript and CSS files, which is actually just caching it from your application server or wherever you are storing those files and caching it in CDN, and all your users are just getting that files from here. And maybe you have 1,000 different versions of your asset files, but CDN is only most likely storing the latest one that's used by all your users. On the other hand, in your actual storage, maybe you just store all these versions in case you need to roll back or something. Now that you are storing this information in two places, one in database, one in cache, you need to keep them in sync so that you return the correct data to the user all the time. And to achieve this, there are two main approaches. So first one is write-through cache. Now let's see how it works. So you have your users, application server, and let's put the cache here. So when somebody sends a request to your application, which requires a write operation, what your application does is it first sends it to your cache. And after it's written to the cache, you need to write it to the database as well. It can be either achieved by the application server, also calling the database, or it can be write-through cache, like cache is writing to the database. So basically, first user is calling your application, then your application calling cache to write the information, and then your cache is calling database or your application calling database to write that information into the database. And then database is saying, okay, I'm done. And then cache is saying to the application server, I'm done as well. And only then a success is returned back to the user. So this part here, it's happening synchronously. And since cache is kind of forwarding this write request to the database, that's why it's called write-through cache. And the second approach is write-back cache. So again, it looks kind of similar. We have our user, application server, cache, and DB. So in this case, user is sending the request, which requires a write operation, and then application will send this to cache. And as soon as it's written to the cache, cache will say, I'm done, and application will say, it's all good, and will return the response to the user. And this part is happening synchronously. And after that, there's an asynchronous kind of writing back to the database here. It can be either a scheduled job which runs every, let's say, 5 minutes, or it can be just after writing it to the cache, it might trigger another asynchronous job just to write it back to the database. So this part is happening asynchronously, while this part was synchronous. But in write-through cache, everything is kind of happening synchronously. And the things we discuss here is mostly for distributed cache. And most of the time, cache is relatively more expensive than your actual storage, because your actual storage might be a disk or block storage, or even a tape storage. For that reason, you might have 1 terabyte worth of storage space for your database, but you can't have the same for your in-memory cache. Most likely you'll just have a couple of gigabytes of memory for your in-memory cache. Then the question becomes which one to evict or kick out from your cache to make room for the new one. So there are different algorithms for this. Let's cover 3 major ones. So one of them is least recently used. So whenever someone accesses an item, you are either setting or updating the time it was accessed, and then you are evicting the one with the oldest timestamp. A similar one is least frequently used. Instead of dealing with the timestamps, this time you are just counting how many times an item is accessed. Every time somebody accesses an item, you are just incrementing the counter for that one, and when you need to evict something, you are just removing the one with the lowest counter value, which was least frequently used. Another one is FIFO, first in, first out. So you don't care how many times or how frequently an item is accessed. If it enters to your cache first, It doesn't matter it was accessed 100 times or it was accessed the last, you still kick them out when you need to make room for the new one. Now let's have an example to understand the differences between all these three. So let's say we have a cache which can store up to 3 entries only. Let's say at time t1, somebody accessed A and we just add it into our cache so that when new request comes in and if they need A, we can just return it faster. And let's say at time t2, somebody accessed B and we just write it into our cache. And people kept accessing A at time t3, t4, and t5. And at time t6, somebody accessed C, and also at time t7. And now we have a new entry, D, somebody accessed D, and now we need to make room for it in our cache so that we can cache this value. Now let's start with the first one. List recently used will just evict the item which was accessed the oldest. Okay, now let's look at our cache here and see which one was accessed the oldest. So the last accessed item was C at T7. And between A and B, A was accessed at T5, which means the oldest accessed item was B here. So to make room for D, we need to evict B from here and put D here instead. Now let's see how list frequently used would work. So this time instead of the times, we need to check the frequency. So in this case, we accessed A 4 times, B 1 time, and C 2 times. Which means least frequently used item is with the count 1 here, because it was accessed only once. So in that case, again, we are just evicting B here and putting D instead. So for the FIFO case, we don't care about the count, because we don't care about how frequently that item was used. At the same time, we don't care about when it was used either, so we don't care about the times and these timestamps. With FIFO, it's super simple. So who entered our cache first? So at time t1, we added A. So this is the first item we added into our cache. And at time 2, we added B. And this is the second item that entered into our cache. And then we already have this. And at time t6, C was the third item we added into our cache. So to make room for D, we need to kick out the item who entered the first. So first in, first out. First in was A, which means that will be the one who should be kicked out. So in this case, we just evict A and put the D here instead. Now let's move to CDN. CDN stands for Content Delivery Network. It's a cache for static files. It can be asset files like JavaScript and CSS, or some images or videos. So let's see how it was working before CDN. So you have your users and your application here. So basically users were calling your application like API orders to get list of orders back. At the same time, they were also calling something like assets, index JavaScript, or CSS, or some images. And the same application server had the assets here, and it was also returning those assets back to the user. But the main problem with this approach was API access pattern is not really same with the asset access pattern, because whenever you make an API call, most likely that result will change even any second, because you are adding new orders, removing some, status is changing all the time, so that data is kind of dynamic. But on the other hand, index JavaScript is something, as long as you don't change your code, most likely you'll serve the same JavaScript file to your billions of users multiple times during a day. So access pattern is relatively different. So at some point, people just moved away from this approach into something like this. So when user makes an API call, it goes to your application. But when they need some assets, you use something like object storage. One example is AWS S3. This kind of solved some of the problems, but still there was a problem. So let's say this is kind of the world. Your object storage is not part of your application server anymore, but at the end of the day, it's a single storage, and it needs to be somewhere, let's say here in the world. So whenever some users are trying to get some asset files like JavaScript and CSS or some image or video files, they are coming to this object storage here instead of going to your application server. But one problem here is you might have some users here in the United States, or you might have some here in Europe or in Asia. So for these users, it's kind of fine, but for these ones and these ones, it's kind of a higher latency request to get those files. So for example, for the video case, it's not really great to send this video all the way back to here. And maybe there are thousands of users here who are trying to access this video, and now you are transferring terabytes of data from the States into the China, for example. And CDN is kind of trying to solve this problem. So you still have this object storage here, which is called the origin server, but you also distribute some CDNs or CDN servers around the globe. So let's say you are having a CDN here, another one here, another one here. Maybe you also want to have a CDN for the users from the West Coast so that they don't need to go all the way to the East Coast to get the video or image files. So before, when you had a user here, it was going all the way to the US and getting the content and sending it over the ocean here. But now how it works is it talks to the CDN, which is way closer to their location. And if that file is not stored or cached in the CDN yet, CDN will go all the way to this origin server and bring that file into CDN. So for the first user, there is not much gain here. But when you have thousands of users trying to watch the same video, only one of them will go all the way to the US to get that content into CDN. But after that, all the remaining users will just start talking to this CDN server, which will be way, way faster. So CDN is nothing but a cache. So it doesn't store all the asset files, videos, or images within the CDN server. It's just storing the one recently accessed or based on whatever algorithm it's using. So maybe there's a hot video right now and everybody is watching it. It will be cached in the CDN and everybody closer to that CDN will just read that file from that location. But as soon as that trend is over and they are not watching that video anymore, it will be evicted from the CDN and other trending videos will be cached in the CDN. I hope now you have a basic understanding of caching and CDN. So if you haven't watched the previous videos about scaling, load balancing, microservices, and databases, you can just click on these links and just watch them. And if you want to learn more about message queues and PubSub, see you in the next video. And if you have any questions or comments, you can use the comment section below and I'll try to answer it.